Okay, I'm going to show you in this video how to do a factorial ANOVA using SPSS. Now, to do this, I'm going to use the data set that you guys have for your SPSS worksheet for factorial ANOVA. All right, so it's in your instructions, the explanation of it. Right. So at the beginning of the COVID pandemic, a group of researchers wanted to test the reactions of people who believed that COVID was primarily a deep state conspiracy versus those who believed COVID was a real thing. They designed an experiment in which they randomly assigned participants to 3 primes: disease threat, individual freedom, and car accident. The prime consisted of having to answer risk probability questions, like how likely is it will you get into an accident, okay, about catching a life-threatening disease, not COVID, losing one's personal freedoms, and getting in a car accident. Okay, this is the variable called condition. Now let's take a little look at that. So, okay, we have these variables. We have conspiracy, and this is basically, did people believe that COVID was a conspiracy or not? And they answered no or yes, right? That's a nominal variable. We asked for their age as well. We also the prime condition, and here we can see that number 1 is traffic accident prime, disease prime, and freedom prime, right? Before being assigned to conditions, participants reported their age and completed a short questionnaire that measured how patriotic they were, okay? And this right here is patriotism, right? Okay. After completing the risk probability prime, they were randomly assigned. Oh, before they did that, they were asked whether they believed COVID was a deep state conspiracy or not. That's conspiracy, right? After completing the risk probability prime, they were randomly assigned to 2 outcome variables to complete 2 outcome variables. Vaccine, where they indicated their willingness to get a COVID vaccine should one become available. This was before vaccines. On a scale from 0, would never get vaccinated, to 100, would for sure get vaccinated. And the second outcome variable was government lying, and their estimate of the probability that the government was lying about at least one aspect of the pandemic, from 0 to 100, where 0 meant that they weren't lying at all, and 100 meant they were 100% sure that the government was lying about something, right? Okay, so let's look at that here. So here we have the government lying. This is the patriotism that they did before the manipulation. And then willingness to get the vaccine is right here. And fear of dying, I can't remember where that was in here. Anyway, what I'm going to do to show you today, you guys are going to have to test the effect of prime condition and conspiracy beliefs on attitudes towards COVID vaccination, which was the dependent variable vaccine, okay? What we're going to do here for demonstration purposes, we're just going to test what when we conduct research, we want to make sure that factors like age are balanced across conditions, right? So we're going to test how age relates to these different things, okay? So what we're going to do is we go analyze, general linear model, just like we did for normal ANOVA last week, and univariate, right? Okay, let me switch to this little window, which should be here. Let me see where I can get this. It's very awkward how it doesn't show you the actual, because I don't believe you can see this, maybe you can see, hopefully you can see where it says univariate, okay? We place age in the dependent variable, okay? And our fixed factors are going to be our 2 factors, or two independent variables in our ANOVA, okay? So we have, do you believe COVID was a deep state conspiracy? For some reason, I keep calling that space. Or, and your prime condition. These are our 2 factors, okay? So I believe in your assignment, in your SPSS worksheet, I believe we call the conspiracy as factor B and prime condition is factor A, but it doesn't really matter, right? You can put them there in either order, right? Okay, So then we can do various things just like we did with our regular ANOVA. Okay, first we're going to select options. Okay. And we're going to select descriptive statistics and estimates of effect sizes, just like we did with regular ANOVA, right? We want to select EM means, which is estimated marginal means, and we're going to put everything in there. We're going to put overall conspiracy, condition, and the interaction, which is conspiracy times condition, right? And then we can hit continue. We can select compare main effects if we like, which is probably a good idea, and compare simple main effects if we want. And we can adjust it. Before they're going to give us confidence intervals, we can adjust it for, we're going to leave it for none right now, right? Hit continue. Okay, post hoc tests. This is appropriate for the condition, right? We can put condition over there. It's got 3 levels. And we can select Tukey. All right, continue. Okay, plots. Now, this time for plots, we can decide. So horizontal axis, we're going to get a line plot or a bar chart. So let's put conspiracy on separate lines. Well, it doesn't, we can do it both ways. In fact, we're going to do it both ways. So we can look at it, the differences, right? I hope I did that. So we can put it both ways. One will be in horizontal, one in separate lines. We can select bar chart or lines. Let's leave it for lines for now, okay? And hit continue. Now we've got everything, okay. All right, now I do need to change my window. So let's have a new share, output window. Okay, so here we have the SPSS results. And we can see our 2 factors here. We had 51 people who did not believe that COVID was a deep state conspiracy and 53 people who did, which is nice and balanced. And we had, 32 to 37 people in the 3 conditions randomly assigned to that traffic accident prime, disease prime, or freedom prime, okay? This just shows us our descriptives, this table right here, our descriptive statistics by condition. So, total mean age for people who thought no was 35.55. People who thought yes was almost 41. So that looks like there might be a difference there actually, which is interesting, right? And mean ages for the 3 prime conditions seems about the same. So that looks good. All right. So now this test of between subjects effects, just like with the regular ANOVA, is where we're going to check for our statistical significance of each of the prime conditions, right? So we're going to look down here. Let me get a little pencil so I can show you this better. All right. So here, right here, conspiracy condition. So whether they believed COVID was a government conspiracy or not, yes or no, right? And we can see actually there is a significant effect of age on this, right? 0.0 at an alpha level, it's at 0.05. This is 0.04, which means that there is a difference. So we saw in this table up here that the mean age for people who thought it was a conspiracy was almost 41, and the other, I believe, is around 35. So it looks like people who believed it was a conspiracy tended to be older, which is really interesting, right? However, here we have, let's get a different color pen. This is our second factor, condition. So prime condition, significance. There is no effective condition, right? And you can see partial A squared is less than 0.001. And finally, if we look at the interaction between conspiracy and condition, we can see that there's no effect there. So really, it doesn't matter, even though it does look like older people believed it was a conspiracy. Overall, we can still run this because there's no interaction between conspiracy and condition on age. And anyway, this is for demonstration purposes. So let's go look a little bit more at this, okay? Estimated marginal means. This is the means controlling for other things in the model. So for example, if we put covariates and so forth, okay? Pairwise comparisons. This is for the variable age. This is the same thing we already saw in our overall table up here that tested between subjects effects. Yes, there's an effect of age. Age is related to beliefs in conspiracy and conspiracy beliefs, where older people are more likely to think it was a conspiracy, right? We can look at that right up here. Mean age for people who thought it was a deep state conspiracy is 40.90, and those who did not was 35.60, right? Okay, we can scroll down to more. Now here, where it says pairwise comparisons, we won't be looking at that in this example because there was no overall effect of, just like we talked about with ANOVA, we did not have an omnibus effect or an overall effect of prime condition. If we did, if we had one, then when we would look here to see which of these pairwise comparisons were significant, right? Okay, none were, right? See very clearly. Here we have the estimated marginal means for each, and here we have more pairwise comparisons, a lot of stuff we really didn't need here. And finally, let's keep scrolling down. Okay, here's the Tukey tests. Nope, this is still not Tukey tests. Tukey tests must be way down here. Here we go, post hoc tests, Tukey tests. They're also the same. If the unadjusted p-values are not significant, these certainly aren't going to be. We can look at the Tukey table here. They all have the same values. Age do not vary across condition, which is good. And finally, we have our graphs, right? So I just wanted to show you this to show how you can either put one of your two factors on either one of your two factors on the X or Y axis. And you can see this is, remember, this is mean age. And we can see here that, do you believe COVID was a deep state conspiracy? Those are the lines, okay? People who believed it was a conspiracy, this is yes, were older than people who did not, right? Okay, so you can see it by that. If you scroll down, you can also see it the other way, which you might also be interested in, and you can just see the lines are now the different prime conditions, and they pretty much are all the same as far as age goes, right? And we can see that people who believed it was a deep state conspiracy were older, right here, than people who did not. So this is mean age for people who thought it was a conspiracy. So, you know, over 40, mean age for people who did not. Okay, so a little under 36, okay? So you can also, you could get bar charts. If we double click on this, let's see if we can change it to a bar chart. Sometimes you can, but it looks like you can, element type. Okay, yeah, it won't work like this. I'm going to run it one more time and repeat it slowly, and we'll do it the other way. So to run a factorial ANOVA, hit Analyze, General Linear Model, Univariate. Okay, put your dependent variable in the dependent variable, section. In this case, it was an experiment, but age was not. Obviously, this is a covariate. Here, it's just, I'm using this as an example, but one would do this to make sure you didn't have really big age differences across conditions. You put your fixed factors, your two independent variables, or maybe they're quasi-independent variables or something like sex in the fixed factors condition, right? You select plots if you want. We're going to put bar chart with error bars this time. Okay, you can include a reference line for the grand mean. Okay, so continue. Okay, post hoc tests, put Tukey for condition. That's okay. This is the estimated marginal means. Put them all in there, right? I'm not going to select any of these comparisons. I'm just going to leave that. Options, we're going to have descriptive statistics and effect size, which is partial eta squared, right? And then we're going to hit OK. So here we have the same analysis. I just walked you through it once more. Again, we can see that the effect of conspiracy was significant, and we knew that people who were older seemed to be more likely to believe that COVID was a conspiracy theory. We can scroll down. We can see the estimated marginal means for these by condition, right? The age group for each person by condition. Yeah. Let's get a pencil out here. So let's look, this breaks it down by each cell, right? So we have a total of 6 cells here, right? 3 for no and 3 for yes, the 3 separate conditions. So remember, it's a 2 by 3 ANOVA. 2 by 3 is 6 cells. Okay, and we have means. We can see all these means for the different primes, and people who didn't believe it was a conspiracy, they're younger than people who did. right? It's just giving us an idea. So let's keep scrolling down. Here's the Tukey tests. None of them are significant, as is to be expected, because we already looked at the overall effect of condition on age, right? And here we have some bar charts, which is what I wanted to show you with this one. Okay, so if you put prime condition on the x-axis, you can see belief in conspiracy beliefs. Yes is dark green, no is blue. And by the way, you can change these colors by double clicking on the chart. The y-axis is just the mean age, right? And we can see that in general is pretty much anyone in who people who did not believe it was a state conspiracy tended to be younger, right? It's just mean age. And here, if we do it the other way, we put it groups conspiracy beliefs on the x-axis, and here you can see even more clearly that independently of what prime condition they're in, people who thought that COVID was a deep state conspiracy tended to be older than 40, whereas the others were around 35, right? All right, so that's how to do an ANOVA. Factorial ANOVA, I should say.